Hey there. In this video segment, we are looking at solving logarithmic equations again. But these types of logarithmic equations are a little bit different than in part one. With this type of logarithmic equation, we have logarithms on both sides of the equation, and that means that we use a different technique. Okay, so recalling a couple of things about logarithms, if you would. Well, let's just think about something that's very common sense. Let's say that I've got log base 17 of x, and I know that this is equal to log base 17 of 2.9. Well, what does that imply about x? Well, of course it implies that x is equal to 2.9 because they're in the same place in the equation and they would make the equations equal. And this really comes down to the one-to-one property, and that's really what we're going to use quite substantially in these kinds of equations. We're looking for an equation where we have a log on one side of the equation, which is equal to a log with the same base on the other side of the equation. And if that's true, then we can drop the log part altogether and just equate the arguments. So let's take a look. All right, first example that we're going to look at here is log base 3 of 5x minus 1 is equal to log base 3 of x plus 7. Notice that there is one log on each side of the equal sign. They both have a base of 3. Well, what that means is we're not interested in the log at all. We're interested in what would make these arguments equal. So we can just equate the arguments and solve the resulting linear equation. Okay, so 5x minus 1 is equal to x plus 7. Subtract an x from this side would give us 4x. Add a 1 from to both sides, and that would give us 8. And we would have x is equal to 2. Okay, always a good idea to take that and set it back into our original equation and make sure that we don't run into any problems. So here we have log base 3 of 5 times 2 minus 1, which is 10 minus 1, or 9, log base 3 of 9. And on the right hand side, we've got log base 3 of 2 plus 7, or log base 3 of 9. Looks good to me, and so we do have a solution, x equals 2. All right, next example. And this is a little bit different because we have 2 logarithms on the left side and 1 on the right. We have ln of x minus 2 plus ln of 2x minus 3, and that's equal to 2 times the ln of x. All right, so we want a single log on either side of the equation, and then we would be able to drop the logarithm pieces altogether. So here we would condense these 2 logarithms and make it 1 log. Remember that when we have 2 logarithms with the same base, we can call it 1 log of the product of the 2 arguments. Okay, and then on the other side of the equation, we're going to move this 2 and make it an exponent of the x. So this is going to be ln of x squared. Remember, by the power rule, we're allowed to do that. So now I have a logarithm with a base e is equal to a logarithm with a base e. Means I can drop those logarithms all together and equate the arguments. So I'm going to go ahead and distribute the x minus 2 multiplied by the 2x minus 3 on the left hand side, and when I do that I get 2x squared, and x times negative 3 is negative 3x, and negative 2 times 2x is negative 4x, so negative 7x plus 6 is equal to x squared. Okay, and it looks like what we have here is a quadratic. which I'm going to solve. I'm going to see if I can factor it. So I'm going to subtract this x squared from the left-hand side and the right-hand side and set this equal to 0. X squared minus 7x plus 6 is equal to 0. Oh, I can factor this. 2 factors of 6, which add to give me 7. So x minus 6, x minus 1 equal to 0. So I have two solutions. I have x is equal to 6 and x is equal to 1. Now both of these I would want to substitute into my logarithms and make sure I don't generate anything that is negative in the arguments. Okay, so let's put that 6 in. ln of 6 minus 2, that's ln of 4. ln of 2 times 6 minus 3, that would be the ln of 9. And then 2 times ln of 6. That's fine. So my 6 is looking good. Now let's look at the 1. Oh, I think we have a problem because ln of 1 minus 2, that means I'm trying to take the natural log of a negative value. And recall, we are not able to do that. So this is not actually a solution. We only have one solution. X is equal to 6. All right, moving on to example 3 of 4. We have something that looks like this. Log of x plus 5 is equal to log of x minus 1 minus log of x plus 1. So we again want to combine these logarithms so I have a single log on either side of the equal sign. Left-hand side is fine. Right-hand side, let's combine it to a single logarithm. So I'm going to rewrite the left-hand side. Log of x plus 5 is equal to, now recall that when I have two logs that are being subtracted, this is the log of a quotient. So this would be the log of x minus 1 over x plus 1. Okay, now I have two logarithms of the same base. Means I can go ahead and drop the logs and equate the arguments. So x plus 5 is equal to x minus 1 over x plus 1. Okay, good deal. So we have a rational expression, which I don't care for that much. So let's go ahead and get rid of this denominator by multiplying both sides of the equation by x plus 1. Okay, and so these would cancel. Hallelujah. Let's go ahead and FOIL this out. And notice we're going to get a quadratic here when I multiply this. And it's going to be equal to something linear. So let's go ahead and multiply this out and subtract this so that it is equal to 0. So I would have x squared plus 6x, because I've got the 5x and the 1x, plus 5. And then I'm going to move this over 2. So I'm going to subtract x, and I'm going to add the 1. It's equal to 0. So when I simplify that left-hand side of the equation, I end up with x squared, 6x minus x plus 5x. 5 plus 1 is plus 6 is equal to 0. And I think that I can factor that fairly easily. So we would end up with something that kind of looks like this. X plus 3 and x plus 2 is equal to 0. So x is equal to negative 3 and x is equal to negative 2. Okay, so I'm going to take these solutions back up to my initial equation and make sure that they don't generate negative arguments. So taking that negative 3 over here, Negative 3 plus 5 is positive 2. Positive argument, that's fine. Negative 3 minus 1, we have a problem, right? So negative 3 minus 1 gives us negative 4. So this is a problem. And I think actually if we look at that same logarithm and we pull that negative 2 in there, we notice that that is also a problem. And so what we have is a no solution case. Okay. Last example for us to look at here, and we will call it a day, either morning or afternoon or evening or midnight, whatever time it is that you happen to be looking at this video. All right, so we want our logs to look like they're equal to each other. So let's remember what we can do with this negative 2 that's acting as a coefficient now. We can actually put it and let it act as a power. So let's take that and move it. Log base 4 of x to the negative 2 is equal to log base 4 of 9. All right, now I have two logs. They're equal to each other and they have the same base. So I can drop the logs all together. X to the negative 2. Now remember that we have the capacity of writing exponents with non-negative powers, which is what we really want to do. So this is really 1 over x squared, right? When we have an x to the negative 2, it's 1 over x squared. And that whole thing is equal to 9. All right, so we, again, don't like this rational expression. Let's multiply both sides by x squared. And we have 1 is equal to 9x squared, which we can then solve by dividing by 9 and taking square roots. So I think we would get x squared is equal to 1/9. And then x is equal to plus or minus 1/3 when I take the square root of both sides. Now if I take these two solutions back to my original log, I notice that only one of them will actually work, because if I put the negative in, I'm trying to take a logarithm of something negative, which is not allowed. So I'm going to cross out that negative 1 and say only x is equal to 1/3 is our correct solution. All right, that'll do it for this topic. I'll see you next time.